everyone, and welcome to another episode of Interstigation. In today's episode of Interstigation, I will go over 2019 CIME number 7. This is a really nice problem, and this, if you don't know this contest, it is a mock CIME contest that was published on Art of Problem Solving. You can check it out. I will leave the link in the description below. So if you have seen this problem, you probably have seen the solution, but I will introduce a general technique through this problem so that you can use it for future contests as well. That is using the time t as one of the variables that you can graph actually on a graph. So you can turn a seemingly algebraic problem into a geometric problem. Although this problem might not be as famous as the actual CIME problems, but I feel like this is worth going through because it does provide a lot of new insight on how to handle these problems with a lot of people traveling along the road. How do we handle them if there are a lot of people, if they don't give me distances, if they don't give me speed of their travels. So let's take a look at this problem. If you haven't seen this problem, I will suggest you to pause the video and take a look and try to see if you can figure it out. When I first see the problem, it took me about 30 minutes to figure it out, so don't be scared if you can't figure it out or it takes a long time for you to figure out the correct method solving this problem. But this is a very new kind of problem that I've seen on these, and it is certainly very helpful to CIME techniques if you are qualified or aiming to be qualified for CIME. And over here, let's take a look by starting at reading our problem, and I will try to switch up my teaching style a little bit so that I can actually lead you through the solution, not just giving you the solution like, hey, here's the solution. I will take you through the process of thinking and how to think through this solution better and more concisely, not just giving you a solution, because the same problem is not gonna come up again in an actual CIME problem or something like that. So the learning the technique is the most important factor that we are trying to do and trying to get from these mock contests. Alright, so let's get started. So there are 4 people. I will just abbreviate them as A, B, C, and D. That's 4 people are traveling along the road at constant but not necessarily equal velocities. So it tells us not necessarily equal, so it gives an insight that the velocity, it says velocity, so this velocity might be negative. Before we proceed on our problem, we can see that maybe Albert and Bob goes this way and Carrie and Douglas goes this way, or if you will, because their speed is relative, there's no outside influences, there's not something like, hey, there's a tree and look at the tree and I'm 20 miles behind the tree or I'm 20 kilometers ahead of the tree. There isn't, so we can assume one of the characters as staying at rest. So, or having a velocity equal to 0. That is one key concept that will simplify the problem a lot more. And let's take a look. So Albert meets Bob, so A and B. So let's make a little bit chart. A and B at 12 p.m. A and C at 12:20. A and D at 12:32 p.m. And that later the same day, Douglas meets Carrie, so C and D at 12:53 p.m. and Bob at 1:17. So Bob and Douglas at 1:17 p.m. and that we want to basically calculate the time Bob and Carrie meet. So that is a question mark. Well, dealing with time is a bit difficult, so we might want to change it to something rather easy to work with. We like numbers, not like these whatever columns these are, so we can try to convert it into numbers. Since it asks for minutes after the noon, so we can naturally think of minutes to look before we get started on this problem. So that's the minutes. And yeah, the problem starts at 12 p.m. So anything beyond it, we don't care about. We don't care about anything that is happening yesterday, or we don't care about anything that happens before 12 p.m., like 11:59. We don't know what happens, and we don't care about those. We just care about something later. Well, also it says it is afternoon, so it is afternoon. And we will know that since it is in mock Amy, we know that the answer will be 0 to 999, which means that there's nothing happening before 12. So we can add on to that, just say minutes after 12 p.m. So that would be, so that's just obviously 0, that's 20, that's 32, that's 53, that's 60 plus 17, that is 77. And each of these, if we subtract the neighboring times, we get that's 20 minutes, that's 12 minutes, that is 21 minutes, and that will be 24 minutes. All right. So now we are fully prepared to start on this problem. So if Bob and Carrie meet n minutes after noon, fine, compute n. Well, we don't know anything about, well, what distance they covered. That is unknown. What velocity they have. We just know that they have constant velocity. But we don't know what velocity they have, so that is still a mystery. We don't know anything about it. So what do we know about these? All we have on our hands, all of the tools, all of the information that they give would be minutes, right? So what is the most important thing that we can deal with minutes? Well, let's get started in a wrong way or common sense way that we might start thinking about after looking at this problem. Well, we will say that, hey, if we don't know distance, we can just set them, right? Yeah, distance, D1, let's say that is, let's say DA, DB, DC, and DD, I guess. And velocity, we don't know the velocity, we can set them as VA, VB, VC, and VD. Well, if we take a look at them, A and B meets as 12 p.m. We can't get anything out of that. A and C meet at 12:20. So the 20 minutes times their sum of their velocity, so A, VA plus VC, and that is equal to DC. Oh, here is the distance of their initial. So we can put DA at a distance line, so we can have like this at 0 and dB. So it's the initial position that they are in. So 20 minutes after, they have this. And what would we see? 32 minutes after, we get A and D. That is equal to DD. And 53 minutes later, we see that is C and D. We get that. Let's assume in this order. We don't know if it's in this order, but we know that it's DC minus DD minus DC, and we need to put an absolute value about it. Actually, we might want to do absolute value for all of these because we don't know if the velocity is positive, but since this is the wrong way of actually solving this problem, I will just leave it like this. And the last information that we would have was 77, and that is B and D. So that will be D minus dB. And look at how many variables we have. We have VA, VB, VC, VD. We have DB, DC, DD. That is 7 variables. We need 7 equations. How are we going to get 7 equations out of this? Counting A and B at 12 p.m., although we've already used it, assuming this is 0 and the starting time is 12 p.m., we cannot get 7 equations. Even if, because we want this value, this minutes, the M that they give in the problem, M times this, B and C, that is equal to what? DC minus dB. Well, even if you can manipulate the algebraic expressions with all of these annoying absolute values to get the correct answer, it's going to be tedious and annoying, and we don't want to do that. That is not an optimal way of doing it. So, the algebraic way doesn't work. We need to find new and creative ways to try to solve this problem in a clever way that we might think of. Well, as I've hinted in the title, you might have seen it. I've hinted it in the beginning of this video that we can use this thing called t-axis. That is mostly used in physics, but we can bring that to mathematics, and that is actually a perfect spot for it, that perfect problem for it to solve, and we can use t. Well, we would still have our x, so this would still be our x-axis, or our distance axis. You can put a d or whatever, but I'm just going to use x because most mathematicians like x. So that is a number line. On the vertical, however, I'm going to do something strange. I'm going to put a t-axis. This might not be something strange if you study physics, but with the t-axis, we can represent a lot of the things that we couldn't with algebra. So that is turning an algebra problem or seemingly algebra problem into a geometric problem. And that, let's take a look at this. So t and x. Well, we would still have something with, let's say, a starting point. Let's say that, well, A and B starts at the same point. Let's say that is the origin, so A and B. And we will have C somewhere and D somewhere. And this t-axis, we don't really need the other half of it because we're just interested in 12 o'clock or 12 p.m. and beyond. So let's extend this t-axis a little bit more, so give us a little bit more free estate. So here we go. Let's take a look. How can we make this to represent and eventually find M? Well, if this is the x-axis, then at this point, this linear one-dimensional point, that is going to be 12 p.m. Or if you don't like this representation, which I don't like, it's 12 p.m. Who knows what 12:00 means? We only interested in numbers. We can put 0. We can put 0 minutes after 12 p.m. So over here, that is 0. T of 0. So at this axis, t is equal to 0. Well, that is similar to y equal to 0, but we're going to use time as one of our axes. So that is t equal to 0. If we have something over here, let's say we have something over here that is 20 minutes later. So that will be t is equal to 20. Let's say we have something, what is the next time? Next time it will be t equal to 32. So something over here, we have t equal to 32. And we have t equal to 53, which is 21 minutes. So it's something like this gap. And let's take a look. So that will be somewhere here. I will try to draw it as accurately as possible, but that is going to inevitably not going to be accurate. Oh, actually, that is t equal to 53. My bad. And the last one is t equal to 77, which is this. And we're interested, actually we need a little bit more space because I know that these two, B and C, will meet later in time. So as t increases, this t will represent the minutes after. So minutes after 12 p.m. And that is equal to t is equal to, and we get that is t is equal to 77. So how are we going to map everyone's position at 20, 32, 53, and 77? Well, let's take a look. A and C meet at t is equal to 20. So, well, maybe they will meet here, A and C. Well, we don't know really, but we can think of one of the persons to be staying at one point, or they have a velocity of 0, because everything is relative between these 4 people, and we can just let one of them be the position observer and just set its velocity equal to 0 and adjust other's velocity to fit it. So let's say, because the last two would be B and C, and B is at the origin anyways, so let's say B just don't care. B just stays at the t-axis for the entirety of the time. So this will be B. You might not see it, so I will change the color. This is B. So that is B's position over time. So over this time. And how are we going to map others? Well, if we have B over here, since we know that B is stopping at these t-axis, he's not moving, we can make it so that, hey, we already have the points. Since they have constant velocity, and that is very important, this thing over here, constant velocity, that is very, very important, so that it means that it is a line. It is not anything else, like parabolas or exponential functions, nothing crazy like that. It's a line. And everything is a line, including the axes, right? Including the axes. We will have B and D meeting at 77 minutes. So we just have D's position over time as a line, so that would be some sort of like this. So B and D would have a position like a line, like this. So I will move this a little bit so that it fits more. I know it's not perfect, but we'll work with this. And now we have the line of D, so we can do C and D. So C and D, what can we see from C and D? C and D will meet at 53. So it will become some sort of like this, so that C crosses like that. Well, next we need to draw all of A, B, A, C, A, D. We already drawn A, B, so we have AC and AD. Well, this graph is a bit skewed, as I've said, so that will be going through like this. But just pretend that it is a line. Pretend this thing is a line. Well, obviously it isn't, but pretend that this is a line. Well, let me try to fix this, although I might not be able to. Here we go. Let's move this a bit. So let's move this part up to like here. Yeah, nothing's wrong. It's always something like this. And we have the t values. These t values would be parallel to each other. Now it has been fully transformed into a geometric problem. And that is good. I want to find basically this, or just the t value at this point, right? Now, how do we do that? Well, easy. Similar triangles, right? Similar triangles. I'll move this a little bit as well, so that it looks better. Well, let's see. What can we do out of these seemingly wrong lines? Let's see. We want to find essentially this length, so that we can find our length for the other ones. Well, that length is kind of hard to do. Well, we can see that there is a similar triangle at here, over here. Over here, it will be a similar triangle, and let's just use this. Well, we can, in a sense, we can try to find the length of this, and we can try to find the length of this. We need to use more similar triangles. Well, we see that this is also a similar triangle. We see that this over here is also a similar triangle. This. So this and the triangle inside, because there are a lot of parallels, and we can see that there are also similar triangles. Well, let's take a look. How can we get started on all of this math, I guess? Well, we can get started by setting some variables. Well, to get started, let's take a look at this similar triangle first. So these two similar triangles. Well, these two similar triangles is nice. We know that here we have a length of 20. This we have a length of 12, and that it is in a ratio of 3 to 5. So we can just simply call this a 3, call this a 5. We don't have specific distances, so we can just do that. And that wouldn't impact our final result of minutes, because it will just, essentially what it will do is just to enlarge this diagram or stretch this diagram horizontally, but it wouldn't change its vertical value. So let's take a look. Now, what can we do with this information? Well, we see that there is another similar triangle. I know that's a lot of similar triangles, but that's what you will see if you have a lot of parallel lines. So this will be another similar triangle. And let's see. This we've used this, so that will be 21. And over here we have this length. This length would be 32. So the CD, we want to find the CD, so that will be 3 over 21. That times this 3 over 21 times this 21 plus 32. That will be the value of CD. Well, we can do that. We can simplify that as 1/7. That will be, that's 53. So that is 53 over 7. You will see a lot of ugly numbers throughout the way that we will be working, but I will try to set it like I didn't set it for 1. That will be much more disgusting. And I will try to make the numbers as clean as possible, but we do have to deal with some nasty numbers since it is an AIME problem. So, let's take a look. What can we do now? Well, we have the value of this, we have the value of that. Now, initially I said we want the value of this length. This length might help us. Well, now you see this green similar triangle comes into play. Well, let's clean up our board a little bit so that we can see it more clearly. So this over here. Well, that would be, so we have this sum, so that would be 7 as a denominator, that's 35 plus 53. Well, that's just equal to 88. Well, now that comes into play, we see that this length is going to be equal to 53, and we know that this is going to be, that is 24. And we can solve. So that is this length. We're solving for this length. That is 88 over 7. That divided by, so divided by the all of the whole thing. So that is divided by 77. So we can multiply by 77 on the numerator and multiply it by 24 on the numerator and 77 on the denominator. We can cancel out a 11 over here, and that would give us a 192 over 49. Don't have to calculate it out now, but this is the minimal calculation that we have to do for this problem. Now, let's take a look at this. So this and this. Now we can do our final straw. That is the final step. So we know that this is 192 over, that is over 49. Well, we know this length. We can set, alright, we will use a green color. We can set this as x. Now, we can simply just do x over x plus 53. And that is equal to 192 over 49 over what is the value of 5. And we're almost done over here. Let's see. So, well, obviously you will be get into some of the nasty calculations, but this is the cleanest calculation that I can figure out to show it to you guys. So I will put the calculations over here. Well, here we have 49 times 5, that is 192. 192, recall that's 24 times 8, but we don't really need it now. So 192, 49 times 5, and that is x over x plus 53. And that is equal to 192x. That is plus 192 times 53. That is equal to 49 times 5. That is just 50 times 5 minus 5. So which is equal to 250 minus 5. That's 245. 245x. And you can see that 192x, 245 minus 192, that is equal to 53. Well, lucky, we get a 53 here, so that we can cancel out the 53 over here to get an x of 192. But wait, do not put 192 as m, because what we set as x is actually this part, and it wants the minute after noon. So we want to add the 53. So our final answer, or m, is equal to 192 plus 53, which gives us 245. Thank you for watching this episode of Interstigation, and we'll catch you in the next one. Goodbye.